Mhm.
I'm Nausheen Fatma. I'm an applied research scientist at Creator Labs Toronto, and I'll be your host and facilitator for today. Zach would be co hosting this event with me. Zach is a data scientist at ACE. This talk is a part of ACL's Spotlight series. We've had many interesting talks from ACL in the past, including the Best Paper Award of ACL 2020. I request our audience to visit our website to go through some of these exciting talks from the past on our website, ai.science. Today, we have a very special guest with us. We have with us Manling, who is doing her PhD at University of Illinois at Urban Champaign. She would be presenting her work and the system GAIA, which was awarded the best demo at ACL 2020. Her paper is about knowledge extraction from multimodal and multilingual datasets and linking and integrating that knowledge in an ontology. We also have a question answering session after her presentation. So I request the audience, if they have any questions from her presentation and her talk today, they can post it in the comments and I'll be able to get across to Manling for you after the talk. So we welcome Manling. How are you doing today?
Yeah, hi, I'm great. Yeah, I'm very happy to be here to introduce our work. Yeah, thank you.
How was your ACL experience for you this year?
Actually, this year we cannot participate in ACL local physically, but so through the website, I think we can still chat with a lot of people. And actually, during this demo presentation, I think a lot of people can ask questions and we can show materials more conveniently because we are both uh, sharing screens. So I think it's a great experience for me. Yeah.
Yeah. On that note, we also heard that you are building a COVID knowledge graph. So, can you tell us more about that?
Yeah. Sure. So for COVID knowledge graph, we are trying to extract also the entities relations from the scientific literatures. So we extract like chemicals, drugs, and disease from these literatures, and we release this KB so it can public available for everyone. And we're also trying to do some reasoning using that extracted KB. So we are trying to generate the drug report, and we want to provide some parties that connecting the drug and the disease, and provide them to the scientists to help them to do analysis. Yeah.
Wow, that's a lot of interesting work going on your side. So I'll not take much of your time, and this is going to be a very interesting talk, and we can't wait to know more. So over to you, Manling.
Mhm.
Then.
Yeah, great. Yeah, I'm really happy to share our work here, and I think our group mainly work on information extraction. So this demo paper is actually open source system that gathering all the state of the art system in our group. So I think it's a great tool for everyone to use. And for this system, we are trying to public information extraction tool because currently most information from like news and also a lot of uh, posts, and we want to get we want to understand them. However, for machines, the first step to understand this unstructured text is to extract the structured information. So that's why we want to do information extraction to firstly extract the structure, the entities, relations, and the events, and then we can do better reasoning and get back to the humans. So for the information extraction here, we mainly mentions information graph. For example, given the sentence, we can extract this person, and we also can extract this person have an action like Sue, and this Sue is an event related to this person, and this person also participate in another event like divorce, and we want to find what the other participants in this event and how these entities are related. And for our system, we also consider the multimedia part because currently news data are presented via multimedia. And from the image side, we can always extract some information that are missed on the text side. So, for example, the person being transported is using a stretcher, and also here we can see that the attacking is using a bomb, so that there's fire here. And so from the image side, we can get the complementary information compared to text side. And therefore, we have the multimedia event extraction. This is a new task compared to the traditional text event extraction. And what we want to do is to extract the image as an event and also try to locate the visual arguments in the image. For example, here we only know that the troops is deployed to some place, but we do not know the vehicle. And from the image, we can know what the vehicle is and also know the specific details about this vehicle. As a result, we built a multimedia information extraction system. And for this system, we have not only text IE and also have visual IE, and then we do cross media linking to merge them into a multimedia KB. So firstly, given the multimedia news, we did the visual KB construction. And the first step is to extract the visual entities such as the vehicles and also the person. And after that, we can conduct the visual linking. So visual linking is basically trying to link the visual entities we just detected to the external KB, and here we use Wikipedia. So we link the landmarks and also link the flags. And also we try to conduct the face detection and link these faces to Wikipedia faces. So here, for the people that we cannot find the linking result in external KB, we're trying to cluster them into a face cluster so that we could know which person are the same person. For example, here, this person is in multiple images, and their scenario is different, but we can extract that they are the same person. And on the text side, we not only conduct the traditional entity extraction, but also try to extend the entity types to fine-grained types. So, for example, for the facilitator, we now can distinguish it's the apartment building, or it's a store shop, or it's a bridge, or it's a tower. So we can have this fine-grained information. And with this fine-grained types, the more details can be used to support downstream tasks. And also for relation extraction, for example, traditional relation extraction, we are trying to extract that this person is located in some place, but here we try to extend it into a more fine-grained types, so that we not only know that person is located in some place, but also trying to know that whether it's because of that person is a resident of that place, or that person is just simply near that place. So we can get more details from these fine-grained types. And for the event part will contain two parts. So for each event, we can extract a trigger word. For example, here the visit shows that this is a meet event, and also the we want to know what is the participants in this event, so we can extract the arguments of this event. And for example, this place is the argument of this event. And for event extraction, we also try to extend the uh, coarse-grained types to much more fine-grained types. So now, given the meet event, we can know that whether it's broadcasting or it's the like a request or it's a threaten. And for attack event, we can know the detailed attack scenario like bombing or set fire or stabbing. And our current information extraction model is the state-of-the-art model because we trying to extract the entities, relations, and events in a joint framework so that we can avoid the error propagation. For example, when we input a sentence into a model, we will classify each word into event type or entity type, and we will form an information network. And when we do the decoding, we will consider the entire network to rank them. And if there some conflicts, for example, this person is a victim of that event, so it should not be the organization. So the organization should be this person, but not the another organization. And the second pattern here, the person is the victim and the person is also being injured. And this pattern appears more frequently, so we can consider the global connections between these knowledge elements. And for now, we know that our system can extend the coarse-grained typing to fine-grained typing. So we extend our ontology. And also, we can deal with the cross-lingual IE. So now, the entity extraction system, we can support around 300 languages. And this system is also public available.
I have a question at this point. Uh, what was the need to have the coarse-grained and fine-grained, categories? I mean, and how did you decide these categories?
So these categories are driven by the product of, from DAPA. So this fine-grained types basically is when people do intelligence analysis. So when they check a lot of news and they want to get the information from that, and then we will. So this ontology is manually made, and it's just these people are trying to find what kind of information, and this types is driven by the application actually. Yeah.
All right.
So I have a follow-up question to that. So when you try to extend these fine-grained types into other domains, so it means that you would have to build an ontology from the start, right?
Actually, here the fine-grained typing system, we are having several components, subcomponents, and one part is the supervised training. But the supervised training is using the Wikipedia fine-grained types. So Wikipedia we will first link each entity to Wikipedia, and Wikipedia will provide several types for that entity. So we can use distance supervision to construct a lot of training data. And since the fine-grained types is from Wikipedia, and that part is actually, I think it's extendable. It can support a lot of scenarios. And for this for this ontology, we only have around 200 entity types. So when we construct the training data using distance supervision, we just select the Wikipedia types that associated to these 200 types. But if we want to extend the fine-grained types, and I think Wikipedia is a general domain, so for other new domains, we can still use the same way to gather the training data using this distance supervision from Wikipedia and to train the system.
Yeah, that makes a lot of sense.
Yeah. And after that, since we have a visual knowledge base and textual knowledge base, we want to do cross-media fusion to merge two KBs into a multimedia KB. So our merging part on the entity side, we have the multimedia grounding. And for this model, we are trying to ground each word into a region of the image. For example, this man is grounded into this small local region highlighted in blue, and also the back is grounded to this back area. So we are trying to use a grounding method to get the multimedia linking. And for this part, since we do not have the target fix the entities, so we can actually support the open vocabulary grounding. And we just calculate the similarity between the word and the image, and try to use a attention-based method to locate this word into the image. So we do not limit the entities, and we can ground anything from the text to the image. And after that, from this cross-media entity linkings, we can merge the knowledge base into a multimedia knowledge base. And currently, our new work is to not only link the entities, but also trying to find the cross-media linking across the events. For example, this is an example we just showed at the first of the presentation, and we can see that this image is associated to the deploy event in the text, and they are actually co-referential event, and this cross-media event can help us to make this knowledge base in a high-level multimedia in a more high-level, support more high-level multimedia analysis. So when we conduct the cross-media event extraction, we are trying to build a cross-media common space. And we said that this is high-level common space because we're not only trying to align word and two image regions, but also trying to align the structure information, like the linguistic structure from text set to the structures in the image set. On the image set, we constructed the situation graph. So we call this situation graph because we use the data set called situation recognition to train it. And for each image graph, we are trying to use image as the center node and use its visual objects as the leaf node to construct a star graph. And for the text side, we are using the existing semantic parser. And here we are using the most advanced one. The most advanced one is MR parser. And this parser is trying to present more semantic rich labels to the edges. So it will have around 150 edge types. And we think this graph is more advanced, and we can take advantage the semantics in the graph. So we use this parser on the text side. And after that, we can get the graph from the image side and the graph from text side. We will use a graph convolution network to project them into a common space. And use the image caption to learn cross attention. So the cross attention is basically the soft alignment between two modalities. And we train this soft attention by reconstruct the entity vector, reconstruct the sentence vectors. For example, here we use the image vectors and also the attention to reconstruct the sentence vector and calculate and optimize that reconstruction loss. And for the image side, we also reconstruct the image vectors to calculate the reconstruction loss so that this cross attention can be learned and we can get the soft alignment between these two modalities. With this cross-media common space, we can get the common representation for two modalities, and then we can train a shared classifier for two modalities. And after that, we can use this multimedia KB to support a lot of downstream tasks. So in this demo paper, we show a news recommendation demo. And this demo is trying to use the arguments and also the event types to recommend the similar news and also trying to find the most dissimilar news. And we can also use this multimedia KB to support a lot of downstream tasks like disaster relief. So we can locate the events into into a heat map using the place attribute, and we can find where the disaster happens a lot, and we can do a lot of analysis using it. Also, if we use the time attribute of each event, we can order events into an event timeline, and it's good for event tracking to see what will happen next. We're also trying to analyze some graph level information. So we visualize our knowledge base into an entity relation graph. And for each entity, we can see what the connections and we can also see what is the most important entities in this graph. Sometimes the graph is very it's very noisy and very crowded, and we think that maybe we can using some reasoning method to select the most important parts so we can highlight them and can help people to do intelligence analysis. And some exciting work is that we are trying to extend the information extraction system to scientific literatures so that we can extract some knowledge base for like scientific knowledge base, and then we can use this knowledge base to mimic the process that people publish papers. For example, we thought when people publish a paper, it's more about creation new edge between two existing concepts or creating a new concept. And it's actually, if we can conduct the link prediction on the knowledge base we extracted, maybe we can mimic the process of paper writing. And this work is also published, and the paper that's generated by this system can actually the Turing task pass rate is around 30, so I think it's pretty high. And for the COVID-19 scenario, we're also trying to extract the knowledge base from it. And we extract the chemical drugs and the disease from it. And for each two given disease and the chemicals, we are trying to extract their connections. So here it shows the connections between these two red nodes. And we can see that there are multiple hop paths between these two nodes, and we will provide these multiple paths to scientists, and also we are trying to rank these paths using the entire knowledge base. And this is the drug reports that's generated based on our knowledge base. So basically, given the disease ID, we are trying to extract the related sentences and also trying to find the connection between them. And so this is another work that I'm not sure whether the time is okay. So if we still have time, I can briefly talk about the EMP work. If we don't have, I can start to answer questions.
I think we can ask more questions about your demo paper now. If we get time, we can ask more questions about that. So one of the questions which I have that, so how do you think these visual entity linking or from images or videos, how is it going to help in the scene understanding part? Like we do have like image to text systems where we are describing what the image is about. How do you think adding an entity linking component or entity extraction is going to help in better understanding the scene?
Yeah, I think it's very important to understanding the thing, because if we do not conduct the anti-linking, we only know that this is the flag, and if we have the anti-linking, we actually know the country of this flag, and also we actually can create the relations between this um, country and these people here. So I think if we do not do anti-linking, the scene graph understanding is more about the physical relations between the visual objects. For example, something is on something, but that relation um, is not very useful in the news domain, because in news domain, I think they focus more high level information. Like here, if we can discover the country of the nationality of these people, then it will. I think it's more informative than that this people is located in this place. So compared to the system without entity linking, I think this um, this kind of high level understanding is crucial.
Yeah. So I have one more question. Like you have done entity extraction from text, and you have done from images. So do you think one task is easier than the other, or what are the key differences which are there?
Yeah. So basically, I think text side is easier than the image side, because on the text side, a lot of first of all, a lot of training data is available. So we actually know how to get a high quality system using this training data. And on the vision side, I think another problem is that a lot of things are a lot of things are vague on the entity on the vision part. For example, if you only see this image, it can be transport event, or it can also be some celebration event, and it can so basically it's ambiguous on the image side, and you need to use the text information to better understand this image. So when you do the visual, like event extraction, I think it's a more high level understanding, and it needs the cross media inference to do that. But for the text side, I think the information is more obvious in some sense.
Okay, all right. I think I'll let Zach take over and ask a few questions from the audience, and if he has his own questions.
Okay, so I have a question regarding kind of like the GAIA system. So from my understanding, the system is very modular. So you have different modules which whose output could be the input of another, right? So can you can you explain sort of how the performance of each module can affect those of subsequent module and whether it's accounted for during your evaluation?
Yeah. I will find the overview page. So basically, I think for the visual part, it will use the text part to do the grounding. And for the extraction part, the visual system will mainly affected by the object detection system. And for the text side, I think the entity extraction is also the most important part, the most basic part. And I think a good thing is that for both modalities, the object detection and the entity extraction on the text side, they are, I think their performance is pretty good. And with that, we can actually trying to do more high-level extraction, like the relations, and trying to link them to external knowledge base. And for the system performance, that when we did evaluation, we found that a component that will affect a lot is the coreference component. So this coreference component actually trying to link the entities that are refers to the same entity in the real world. And if we cannot produce the correct coreference link, then even if we discover the relations between two entities, maybe we cannot put them into the knowledge base, and the knowledge base will be very sparse. So this coreference component, I think, is the main bottleneck of the system, and it actually affects a lot.
So that makes a lot of sense. I would summarize it as a lot of the modules that you already have, like the visual entity extraction and the text extraction, has already performed very well. So you run into less risk of passing the error onto a subsequent system. Okay, and another question I have is, so you mentioned a few application for this system, and it's all very good. But do you see any challenges that would prevent bringing a system like this into industry applications?
Yeah. So I think now the main application is using the attributes, like this recommendation, and also if we want to analyze this using heat map timeline, I think most important part for these applications is that we need to get the attribute correct. For example, when we do the time event tracking, when we extract the time arguments for each event, actually only like 1/3 of events can be extracted, the time arguments explicitly from the text. So a lot of events are actually not mentioning their time. And we are currently trying to apply a temporal propagation system. So basically, it's a temporal guided GCN. So it's trying to look all the events in the graph and trying to propagate the temporal information to others using their connections of entities. And then we can get more correct and also more these attributes, and then we can order them into timelines to support downstream tasks. So I think the main problem is still about the structure information for this event, and I think we need to use the global knowledge, trying to get more more attributes being inferred if they cannot be extracted from text or image.
So yeah, that so a follow-up I would have on that is that as you're trying to expand the system and developing even finer grain details of entities, do you foresee any issues related to data efficiency?
Yeah. So for example, when we extend the ontology, and currently the ontology is around 200 function types. But when we extend the ontology, we think the event function types is the most difficult part. So it's actually the bottleneck to do more frequent event typing, because for events, I think it's highly dependent on the context. So we cannot do distance supervision like we did for entities. And for events, the context understanding, I think sometimes will rely on also the linguistic structures of that sentence. So sometimes the arguments may very far away from that event, and we need to use the linguistic structures to get the connections between them. And I think the arguments is more fine-grained if we want to extend the ontology. So that part is also unexplored.
All right. And the last thing I want to ask you is regarding so you mentioned two to three other applications of GAIA, but I see that they didn't include the visual recognition part. So other than attack events, did you try any other kinds of events, and what were the results like?
Yeah, we also try another events demonstration, and the demonstration and attack is two dominant event types in our data set. So we try these two, and I think it's a great question for multimedia event extraction, because currently I think the event type we focus on is around 8. So they basically the overlap between the text ontology and the vision ontology. But this 8 types is too small to do the analysis. So we are currently trying to extend it to open vocabulary, trying to detect more event types using some zero shot methods. And I think for the current demo, the 8 types we selected, that since it's the overlap between text ontology and the vision ontology, I think their performance seems good because they have both training data for 2 modalities.
Yeah, I think a lot of the time it depends on the training data that we get. Yeah. We actually have a question from the audience, and the question is, can you elaborate more on the paper use case? Yeah, in the end of the slides. So I think it's the paper robot.
Oh, I see.
Yeah, that sounds just fascinating. So yeah, can you elaborate more on that?
Yeah. So this work is a very interesting work, and it's trying to get robots that can write papers and the input of that robot is the old papers and also a title given by the user. So the user will firstly input a sentence, and that title will try. When we do the paper robot, the model will try to extract some keywords from the title, and then we will use the knowledge base from the old paper and trying to do link prediction on the old papers, and then we now then use these predicted links and also the keywords from the title to do a generation model to generate the abstract and the conclusion and the framework and future work. So this generation work is basically using the entities that we extracted from title and also found from the background knowledge base, and trying to use some attention and I think it's just attention-based method to try to generate the new paper abstract and the conclusion. And when we did this work, I think the scenario we focus on is biomedical area. So we use the papers from biomedical domain, and the knowledge base we run a Science IE. It's also public available, and for the link prediction we use a graph convolution network based method to do the link prediction.
Okay, and we have a follow-up from the audience. He was asking whether how you measure the quality of the results of the paper robot.
So the paper robot, I think the main method is still the manual evaluation, because although we can, for example, we can construct some ground truth and trying to calculate blur and rouge using the for example, given a title of a paper, we use the abstract and the conclusion as the ground truth to calculate that. But since for generation task, it's very these two metrics are not sometimes cannot capture whether the writing is good or not. So we are currently using manual evaluation like Turing test to present the abstract from the paper and the abstract that we generated to expert and also non-expert to conduct different kinds of Turing test. And also there's ongoing work about a review robot. So it's basically trying to generate reviews using this generation network and using the knowledge base constructed from history literatures. And in that review robot, I think it's trying to use different criteria. Just like when we do review, we have multiple criteria to score. So in that review robot, it will have generate scores for each criteria, and also trying to compare the knowledge base extracted from the generated paper and also the knowledge base from the history paper to use this knowledge base level comparison to get some idea of whether that paper is good. And I think currently we didn't apply that kind of work in the evaluation. I think that's also a direction to do the evaluation.
So from what I sort of understand, this paper robot use case is more of an exploratory use case that you can extend to other tasks as well.
Yeah. Basically, when we have the knowledge base extracted, we can do a lot of knowledge-driven generation. So that's the generation can not because currently a lot of generation tasks may lose focus to the important information in the input. So with this explicitly extracted knowledge, we can actually better capture the salient information.
Okay, so yeah, we're not really trying to develop a robot that can actually learn by itself.
Yeah, yeah, that's a very interesting direction. Yeah.
Okay, so another question by the audience is that he said he missed the first half you might have talked about, but are you focusing on non-directional graph? In other words, would this work in situation where there are directional dependencies between entities?
Yeah, actually, the relations and the events, they have the direction. So, for example, these are the relations. When we extract the relations, the edges have directions, and we actually know which is the argument 1, which is the argument 2. And for the event part, since we extract 2 parts for each event, one part is the trigger word, just like the visit, and another part is the entity participating in this event. So the direction, it will be the edge is from the trigger to the entity. And with these 2 directions, actually the graph we constructed is this kind of graph. So on the left side, you can see that each event is connected to entity, and the entity will have relations, and the relation is also has direction.
Okay, that sounds great. And with all of this, it's a very complex system that involves, I'm sure, a lot of thought. So, what are your plans for future work?
So currently the system is the multimedia multilingual system, and to support fine-grained typing. And our goal is trying to make this system, firstly, it's more easy. I think we want to use this as a basic tool to support a lot of downstream tasks. So we make it open source system and make it public available, and we want to make it more convenient for people to use. So we are currently try to put all the things into one Docker, because currently our Docker are just separate Dockers, so people may use multiple steps to run the system. And for now, the text system is only one script to run the whole pipeline. And the vision system, we are trying to also embed the scripts together, so we can only have one script to run the entire pipeline. So this is the first thing that we want to make it convenient for users to use. And on the technical part, we are currently trying to not only support more fine-grained types, but also trying to extend the languages that they can support. So we are currently adding with Spanish, and also for the vision part, as we talked before, that we want to add the high-level analysis, like event extraction, to the vision side, and trying to merge the event information of 2 modalities. And also for the linking part, we are extend the linking knowledge base to multiple knowledge base. So we not only have free-based gel names, but also added Wikidata. So this work is actually the GitHub is still I think we are still kept updating the system, because we will I think every time when we have new like model, and when we publish some good work, we will try to add that into this system, and to make this I think we are trying to make this as a basic tool, and have good performance, and everybody can use it. Yeah.
We actually have a follow-up from the audience that asked you the question about directionality. So the follow-up is, does directionality change anything about the pipeline you presented, or would you mostly use the same ideas?
So, for example, for the pipeline now, it will have mention extraction, and then it will input to the relation extraction and event extraction. And for the vision part, we also has the entity first, and then we trying to use that entity to support events. But currently, this is the newly added work, so it's actually updated after the ACL demo presentation, and we already updated it into the GitHub. So we are merging the whole pipeline into a joint framework, and now the entities, relations, and events can be extracted jointly, so that we can avoid error propagation, and we can also take advantage of the global knowledge for each like sub-component. And I think this is a direction that we want to go, that we want to make the system more simple and can use the global knowledge of each component.
And another question is regarding the co-occurrence criteria. I'm not sure which slide that was. But he was asking if he understood correctly that you use the co-occurrence criteria to reject links that are uncertain.
So I'm also not quite sure about the slide. So for co-occurrence, I think.
So we maybe we'll let our audience elaborate more on his question.
Yeah, sure.
In the meantime, Nausheen, do you have any other questions?
No, I think that has been a lot of questions, and it's a very great effort that you're planning to open source this information to the community very soon. So that's a great news, and I hope the audience will like it. So yeah, I mean, now I think we should. The time is almost up, so we should close this session. So if the audience have any more questions, they can follow up with Manling through email, definitely. And so yeah, that's all for today. We have a few more interesting events like these in October. We have one talk reevaluating the evaluation of machine translation metrics. This paper was had an honorable mention at ACL. We also have a talk by Suhaspai on GPT-3 in October. So we look forward for you for you all to join there. So make sure to like and subscribe our channel, and on YouTube as well for more updates. And that's all for today. Thank you, Manling, for joining us and for your time and letting us know these interesting work you are doing.
Yeah, thank you for the opportunity to do this great. I think the platform and this kind of YouTube live stream is great. Yeah, thank you.
All right. Thanks all, and have a good day.
Have a great day.